All right, in chapter 3, we're discussing exponential functions and logarithms. We're going to start with this property of equality for exponential functions, where if you have the same base, then you can set the exponents equal. So b to the x equals b to the y, then you've got x equals y. So here, part A, I've got an equation with the same base, 3 equals 3. And so if these are equal, then their exponents must also be the same. So we can set the exponents equal. And so I would subtract x to the other side and add 1 to the other side, and you get 3. Let's look at B. The bases are not the same. So we're going to have to change 4 so that it looks the same. So I can change 4 into a base of 2. So I'm rewriting the equation, except 4 I'm going to change. The exponent is still the same. So 4 I'm going to change into 2 squared. And now my bases are the same. So now I can set my exponents equal. So I've got 3x equals, and then 2 needs to be distributed onto the x plus 2. So I've got 3x equals 2x plus 4. Subtract 2x to the other side, and you get x equals 4. On C, we are going to change 1/9 into a base of 3. So if you think about 9, 9 is 3 squared, right? So 9 is 3 squared. That'll get you 9, but I want 1/9. So how do I get 9 on the bottom? So what would we do to the exponent to get 9 on the bottom? Well, you make it negative. So the negative moves the 9 down there. And now the bases are the same. So I've got top equals top, exponent equals exponent. And I can add 1 to the other side and then divide by 2. So negative 1/2 is the x value. See if you can pause the video and try the next two on your own. So looking at this, I've got 4 and 8. Now I can't change 8 into a base of 4, but I can change them both into a base of 2. So I've got 2 squared, and I can change 8 into 2 cubed. And so now they have the same base, and I can set these exponents equal, and I'm going to need to distribute the 3 and the 2. So I'm going to have 2x plus 2 and 6x plus 9. Let's subtract 6x to the other side, subtract 2 over to the 9, and divide by the negative 4, and I'm getting negative 7/4. And then here, E, I've got 8 and 16. Now, I can't change 8 into 16 with exponents, but I can change both of them into a base of 2. Both of them into a base of 2. So 8 is 2 cubed. And 16 is 2 to the 4th, but 16 is on the bottom, so you make it negative 4th. And so here we're going to have bases match, so set the exponents equal. Distribute that 3. 3x minus 6 equals negative 4. If you add 6 to the other side, you get 2. Divide by 3, you get 2/3. 2/3 for that. All right, so that's getting the bases to match. Now let's say we've got a logarithm. So this is how you change from logarithmic form to exponential form, and from exponential form to logarithmic form. So what this does is we have an equation like this where we want to solve for x, but we can't find x if it's in the exponent. So we had to figure out a way to get x out of the exponent, and that's how this log is created. If you see, the exponent is the log. So the exponent, to find x, you are taking the log. So the log is the exponent. Here we're just going to change them into exponential form. So to change this into exponential form, you've got a base of 6, that's a big 6. The log equals your exponent, so 3, and then 216 is what it equals. And it should make sense. 6 cubed is 216. Here my base is 25. So, and then the log equals 1/2. So, so the exponent is 1/2, and then equals 5. 5 to the 1/2. 1/2, remember, is square root, so square root of 25 is 5. I've got base 7. The log equals 1, so the exponent is 1, and it equals 7. And 7 to the first does equal 7. Here we're going the other way. So we have exponential form, and we're going to write it in logarithmic form. So this would be log base 3 of 81, and the log equals the exponent, so equals 4. So this one, so think about it for a second, try it. So we've got log base 13 of 13 equals the exponent 1. Try the next one. You should have log base 5 of 1 over 125 equals -3. All right, let's turn it over. So here, our helpful hint is that you want to get the same base. Get the same base. You can't see that. The hint is to get the same base. Because if you have log base b of b to the x, the log base b of b cancels, and you just get x. So looking at A, I've got log base 3 of 81. I want to get 81 to have the same base as the log. So I change 81 into 3 to the 4th, and then those cancel, you get 4. So here I want to change 1/16 into a base of 2. So that'd be 2 to the 4th to make 16, but it's on the bottom, so negative. And now those cancel, you get -4. Log base 9 of 1. So how are we going to get 1 to have a base of 9? 9 to the what? 9 to the what is going to give you 1? 9 to the 0. Anything to the 0 is 1. So those cancel, you get 0. And then we've got log base 7. This will be 7 to the something. Well, 7 squared is 49. And since 49 is on the bottom, it'll be negative, and then we get -2. Here, we've got some simple equations that we're going to solve with logs. So it's impossible to get the n out of the logarithm. So what you're going to do is change it into exponential form first. So 3 to the 4th is n. And now n is isolated. So n is 3 to the 4th, which is 81. Here, same thing. We're going to get x out of the log by changing it into exponential form. That'd be 5 squared equals x. And then x is 5 squared, so 25. Same thing here. We're going to change this to exponential form to get this 3x plus 1 out of the log. And then we get 16, subtract 1, divide by your 3. So x equals 5. As we're looking at logarithms and exponential functions, it's important to talk about a special number, which is very much like pi, and it's called the Euler number. Or you have sometimes heard of it as the natural base E. We use this a lot in science. The number E is approximately 2.718, just like pi is 3.14. So let's use a calculator to find the following expressions. So we've got E. So find E on your button. For this one, it's on the natural log button. It's usually around your log buttons. So I've got E to the 4th, and I'm getting 54.598. And then here we've got -4 times e to the third, which is negative 80.342. And then e to the first would just be 2.718. You can try that on the calculator. So whenever we have just the word or the abbreviation log, we are assuming there is a 10 there. So base 10 is the common logarithm. So instead of putting log base 10 all the time, since it's so common, they just leave it off. So you're going to see it written as log 6. So if there's no base, then you're assuming the base is 10. But E is also very common, so we wanted to make an abbreviation for E. So we can't just leave it off, because if we leave off the base E, you're going to think it's 10. So we totally change log E into ln, log natural, because it's the natural base. So whenever you see ln, that means log base E. So here they're just wanting us to rewrite it in exponential form. So remember, this is an invisible base 10. So it'll be 10 cubed equals 1,000, which should make sense. On this one, they want it to be written in logarithmic form. So it'd be log base E of 2.718 equals 1. But log base E, you're never going to see that. So change that to ln. Here, solving the equation, just like the first few examples, the bases match, so you can set the exponents equal. So this is just showing that E acts just like any other number. Subtract 2x to the other side and divide by your 3. And here, again, we need to change it into exponential form, but this one is missing that little invisible 10, so that can throw you off sometimes. Just remember, if there's no base, then it's a 10. And if it's an ln, it's E. 10 to the first is 10. Subtract 3 to the other side, and we get 7, and then divide by 5, so 7/5. It's an ugly 7/5. 7/5. Slightly better.